what we will be seeing today is data modeling. How do you model data? How do you model data? We did see earlier that there are several kind of data models. We did see something called a relational model. We even saw that there is something called ER model, object-oriented model. You even have an XML model. You have something called the hierarchical model, the networking model, out of which, these aren't used much now, the hierarchical and the network model. These are the four models which are being used very often, and out of which we did see what do you mean by a relational model, where you will have something called tables, a concept called tables, a concept called databases, a concept called attributes, and even you will be having tables which are connected so that you avoid redundancy. So all this we did see last day. What do you mean by a relational model? Now, next we will see about something called ER. ER is nothing but entity relationship model. ER model or the entity relationship model. Now, in the ER model, what we do is we give importance to two concepts. A concept called entity and a concept called relationship. Now, we will be seeing in detail about each of these. Now, first, we will see what do you mean by an entity set. Now, before we go to entity set, we will see what do you mean by an entity. Now, an entity is an object which exists and is different from other objects or distinguishable from other objects. For example, you can say a person. Okay, a person called Akhil P. You say this is an entity. Okay, I do even have another person called Akhil Matthew. Akhil Matthew, he is also an entity. Imagine I talk about a person called Vishnu. A person, Vishnu, he is also an entity. I do have four Shrutis. Shruti, 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 and Shruti. Shruti A, Shruti B, Shruti and Shruti D. Each of them are persons. Each of them are distinguishable from the other one. Shruti A is different from Shruti B, which is different from Shruti C, which is different from Shruti D. All these are different persons. I can say each of them is an entity. So, when I talk about person, an entity called a person, I do have a way of 1, 2, 3. I do have 7 entities. Okay, when I talk about person, I do have 7 entities. Now, let's see what do you mean by an entity set. Now, the collection of all these entities. I do have 7 people over here. I say that all these 7 people, they belong to the entity set called person. Okay, so this is a set of persons, and each person is distinguishable from another person. So entity is an object, and entity set is a set of the entities of the same type. Now imagine I do have an entity called Anne, and I even have another entity called, let's say, your Dean Vidyavan. Okay, I do have an entity called Anne. I even have an entity called Vidya. Both of them also fall under the person set. Now imagine you are talking about an entity called student. Okay, we are no longer talking about person. We are talking about an entity set called student. I have both my Akhils. I have Vishnu and I even have my 4 Shrutis. I have my 4 Shrutis. I'm talking about student, and all their details will be there. You very clearly know that all of them are entities, and together, all of them, they are under the entity set. And now, let me talk about 2 more entities called Anne and Vidya. Their details are completely different. They are different from student. So I cannot say that they are coming under the entity set called student, because they might be having some other details. Like example over here, you might be having your UG marks, the university in which you studied and all that. But here, the details which I want are completely different. Like let's say, date of joining, qualification, year in which the PhD was obtained, and so on. The details are completely different. So I can say this is distinguishable from this. So I can say that Anne and Vidya, they do not belong to student. Instead, I can say they belong to another entity set called teacher. So that is why it's written over here, distinguishable from other objects. Okay, so student, the attributes will be completely different from an attribute called teacher. You can think about company, event, plant, product. All of them, you can think it to be entities. Now, let's see how you represent entities. Representation of entities. Now, representation of entities will happen with all the members of the set. Now, imagine, you can write together with me, you are talking about an entity called student. Okay, so let's say I'm talking about Shruti. Yeah, I'm talking about an entity called Shruti. What all will you need to describe a person called Shruti? Now, representation happens in an ER like this. You write student equal to. Okay, you write student equal to. You open up a bracket and then you write the descriptive properties. Now, Gloria, she gave me a few attributes. I'll just write them down. Name, comma, age, comma, her UG marks, comma, date of birth, comma, address. This is how you represent an entity. So an entity is represented with the help of the descriptive properties. Now, these descriptive properties are called attributes. The descriptive property, they are called by attributes. I even call them members of the entity set. They are even called, I do have an entity set called student. All these are members of the entity set called student. Okay, now look here. I've given a few examples. I have something called instructor. Instructor is an entity set. These are the members of the entity set. Instructor can be described by giving an ID, a name, and a salary. It's even called as attributes. The same way, I'm having something called a course ID, title, credits. All these are called members or the attributes. Now, we do have something called primary key, which we will be learning later. Now, let's see how you represent it in an ER. You are now very clear about what is an entity, what is an entity set, and what is an attribute. Okay. Now, this relational model, as you all remember what we saw yesterday, relational models, you have the concept of rows and columns and all these connections and so on. Now, representing things in a tabular form or drawing it in a tabular form, it is quite difficult. That is why people, they thought they'll go for something more, diagrammatic representation. So instead of doing it or representing it directly with tables, they thought they will represent it in a much more easier way where you can do it via diagrams. So that is why we did have a model called ER diagram. Now in ER diagram, what you do is you will have a concept like this. You will have rectangles. Okay. Now imagine I am planning to represent an entity called student. I will make a small compartment on top over here, and I will write the entity name on top, student. Okay. And I did get a few details earlier, like name, the UG marks, then I got date of birth. I even got address. Okay, so all the details or the attributes I have of student, I will write it in the second part of my rectangle. So this is how you represent an entity and its attributes. Okay, this is how entities and attributes are represented in an ER diagram. Now, you do have a concept called primary key, which we will be learning after 10 minutes. Now, just have in mind that the primary key, when you represent an attribute, which is the primary key, you will always be underlining it. The primary key will be underlined, and the primary key should always be the first attribute in the entity diagram. The primary key should be the first attribute, and it should be underlined. What it is, we will see after a 5 minutes. Now, the next very important thing is something called relationship set. In ER diagram, the most important thing is relationship. Now, relationship is an association among several entities. Association or a connection. An association or a connection between entities. Now, look, you will have a student entity. You will have a student entity, and you will have even an instructor entity with all these attributes will be there. I say this is entity 1 and this is my entity 2. Now, if you think, there is always a connection between student and instructor. Like, when we saw in our ERP earlier, Fedina, I will be able to teach you a subject, or might be more than one subject, DBMS and DBMS lab, which means I will be able to give you marks for that. I will be able to mark you attendance for that. I will be able to give you assignments. All the assignments which you write for DBMS, it will come only to me, it will not go to anybody else. So there is always a connection between an entity called student and instructor. There is a relationship. Now, you can say, we can give any name for the relationship. They have given a relationship name called advisor, or you can say teachers. Okay, or taught by. So I can have a relationship between student and instructor. I can say student is taught by the instructor. So, both these entities are connected with the help of something called a relationship. Now, if you look mathematically, a relationship is a mathematical relationship between more than two entities. Okay, you have one entity, you have two entities, you can have a relationship. You can even have a relationship with more than two entities. All that is possible. Now, let's see how you denote it. Now look here, I've got two entities over here. I have an entity called instructor, and I even have an entity called student. Okay, I've got two entities called instructor and student. I've even filled up the values inside. Now, very simple, you can draw lines to denote the relationships. Now look here. By this I mean, okay, look here. In my earlier diagram, I had student over here and instructor over here. And then when I read it like this. Student is taught by instructor. But you know, when I have it the other way around, instructor first and student later, I write my relationship like instructor teaches, normal English. Okay, you know, when the subject changes, taught by teaches, when it gets reversed. So here what I have is, I have this particular thing. I have instructor over here, and then student, which means, you know, instructor teaches a student. So let's see how you read it. So it means like, you know, the instructor called Crick, he teaches only a student called Tanaka. Cats, he teaches both Shankar and Zach. Srinivasan teaches Brown. I'm using this relationship. Kim teaches Oy. Singh teaches Chavez. Einstein teaches Peltier. Okay, so pictorially, when you represent, you simply draw lines. You simply draw lines between the related entities. Now, let's see how we draw a diagram. You know that when you draw the ER diagram, entity happens in a rectangle where you write the entity name on top and the attributes below. You even have another entity called E2. You write the entity name over here and then you write the attributes below. To connect them, you will be using diamonds. You will be using diamonds to show your relationship sets. And inside you can write advisor or teaches, taught by. The word whichever you feel like, you can write it inside your diamond. Very simple. When you read from left to right, you read it like this. Instructor is advisor to student. Okay, normal English. When you read from left to right, you read it like this. Instructor is advisor to student. And when you read in English, it should give you sense. It should give you meaning. Then you say your representation is perfect. Now, relation sets, at times, they can have attributes. Need not have attributes always, but you know, at times, based on your requirement of the system, relation sets can have attributes. Now, let's say instructor is advisor to the student. Okay. Now, let's say Crick is advisor to Tanaka. And this student called Tanaka, she was assigned to Crick on this particular route. The same way, Peltier was assigned to Einstein on a particular date. So actually, this date, it has nothing to do with the instructor entity. It has even nothing to do with the student entity. But this advisor relationship must have an attribute like, you know, when that student was assigned. So in such a case, not always, in such a case, the relationship may have an attribute. It need not always be date. It could be anything. Okay, so there are cases where relationships can have attributes. Now, whenever there is a case where a relationship can have an attribute, you will be denoting it with broken lines. Okay, relationships with attributes, they are denoted with broken lines and in a rectangle. Now you might have more than one attribute. Let's say date and even let's say Zoom ID. Imagine if it is online. Okay, for the teaching between a particular teacher and a few students, you will even have the date on which it was assigned and even the Zoom ID for all their meetings. Now, this will be represented in a rectangle. Like you will write over here, date and the Zoom ID. You will not have this initial compartment. So this is how you represent relationship sets with attributes, with a broken line and a rectangle. Before we go into roles, let's see about degree of a relationship. Okay. Now, there are several kinds of relationships or several degrees of relationship. First, we will see the very simple called binary. Now, imagine you do have something like this. Go very simple. You do have a student. You do have an instructor. They are related. How many entities are here? There are only two entities. You have an entity called student and you have another entity called instructor. There are only two entities. So you say the degree of this relationship is 2. Let's see another one. Non-binary. Okay, look here. The same thing which we saw earlier. Instructor, student. Okay. Now, you even have one more entity. Let's say you have an entity called project. Okay. So the project, it will be having something called a project ID, a project name, project organization, and so on. Okay. Now, forget this portion. You are very well familiar with instructor and student. Now, when you are having a project mode, the project actually student works on project. Okay, project is guided by instructor. So now all these together, you can fit it in a single ER diagram. Okay, you can fit up everything together in a single diagram. Then what you can do is you can name this particular relationship as project guide. You can read it like this. Instructor is project guide to student. Okay, project, done by a student. Project is guided by the instructor. Everything is fine. Okay, so in this particular ER diagram, you do have 3 entities. You say it is a non-binary. Because it is 3, you call it by the name ternary. Ternary relationship. 3. Okay, students, they work on research projects under the guidance of an instructor. So relationships where you have 3 entities coming in, you call them to be a ternary relationship. Now let's see types of attributes. Very, very important. Types of attributes. There are several categories of attributes. We go one by one. We'll see first something called simple and composite attributes. First, we will see what do you mean by a simple attribute. Now, simple attribute is an attribute which can be no more splitted. Which can be no more splitted. Such an attribute is called a simple attribute. Now, try telling me attributes of simple, something which cannot be split up. You call that to be simple attribute. For example, your phone number. Phone number is a simple attribute. Your age is a simple attribute. Okay, your mail ID can be a simple attribute. Mail ID also we can split, but anyway, let's be very simple. All these are simple attributes. The composite attributes, from the name itself, you can understand, they are attributes which can be splitted. Okay, so type in your chat box things which can be splitted. I'll do one thing, need not type. I'll end the meeting, you can log in again. So let's say you are talking about name. You're talking about name. So you see, in your passport, actually your name consists of 3 things. Yeah, you can have a first name, you can have a middle name, and you can have a last name. This is usually how names are being captured everywhere. It can be split. Okay, you think about address. Address also can be split. Usually, when you go into Flipkart, Amazon, and all, they ask you, what is your house number? What is your house number? Your street number, a landmark, and then they ask your PIN code, they ask your district, they ask the country, and so on. Address also can be splitted. But you know, when you come over here, phone number cannot be splitted, age cannot be splitted. That is why earlier I told you, mail ID can be both. Mail ID also you can actually split it, isn't it? You can have your domain name, okay, the extension and all that. But anyway, that's things simple. Mail ID cannot be split. Okay, so composite attributes are attributes which can be split. Name, I can have it in first name, middle name, and last name. Address, I can have street, city, state, postal code. Street, again, I can have street number, street name, apartment number, and so on. So all these are examples of composite attributes where you can be dividing it into sub-parts or other attributes. Now, we'll go for the next category, single-valued and multi-valued attribute. Single-valued attribute means you can have only a value. For example, if you think about age, at a particular point of time, you will have only one age. Let's say your age is 21. That's it. As of now, your age is 21. You do have only a single age. Or you think about your first name. You will have only one value for your first name. Okay, imagine your first name is Sachin. That's it. You won't have another first name. So attributes which have only a single value, you say it is single valued attributes. Now, attributes which can have more than one value, you can say it is multi-value. You can, of course, have 2 phone numbers, isn't it? You can have a landline number. You can have mobile number 1, mobile number 2, alternate mobile number. Just like, very interesting. You say, the father 1, father 2, father Gulf, father Kerala, wife 1, wife 2, all that. You can have different phone numbers. All those kind of attributes which can have more than one value, you say it is a multi-valued attribute. Now type in your chat box another attribute. Derived. From the name itself, you can get it from another attribute. It can be computed from another attribute. Now imagine I do have student. Okay, I do have student ID, I do have student name, and I do have the date of birth. Now, if the student tells me he is born on the 31st of December 1990. Age, actually, I need not make him enter. Age is something which can be calculated with the help of another. attribute. Okay, so I say age is a derived attribute. If he's born in 1990, I can automatically calculate his date to be, let's say, 30 years of age. Oh my God, he's too old to be a student. 2000. Yeah, I can calculate his age to be 20 years of age. I need not enter. I need not enter the age. With the help of date of birth, I can calculate the age. So such an attribute which can be computed from another attribute, I call it to be a derived attribute. Now in a chat box, try telling me another derived attribute. You enter all the marks, total, average, grade, all of them are derived attributes. Let's see how do you represent all these in a ER diagram. Okay, now as you all know, entity, you will have a big fat rectangle. On top, you will be writing the entity name. The first one will be the primary key. Okay, and then after which you will be writing all the attributes. Now let's see how you write the attributes. Now, simple attributes, you directly write it. Okay, simple attribute. This is a simple attribute. This is a simple attribute. You directly write it. Okay, now just quickly revise through all these attributes. You have single, multi-value, derived. You even have composite and simple. Okay, so simple, you directly write. Composite, you write it like this. Okay, name, push a tab space over here, and then you write name, can be a first name, the middle name, and the last name. So, you know, when you have this kind of a notation, it is understood that name is a complex attribute. Okay, now, address. Address can have street, city, state, and your PIN code. You push it a tab and then write. Street again can have all these attributes. So this is how you write complex attributes. Okay, under that you push a tab space and then you write simple and complex. Multi-valued attributes, you always write it in these curly brackets. Multi-valued, you write in curly brackets, denoting that it can have more than one value. Okay, now if you have a derived attribute, you will be ending it up with these brackets. Derived attribute. Okay, you will have an open bracket followed by a closed bracket to show that it is a. We'll now go on to a new topic called cardinalities. A topic called cardinalities. All of you might have already dealt it in mathematics. Cardinalities or mappings. Now, cardinalities means the number of entities to which you can associate an entity through a relationship. Now, cardinalities for binary relationships, they can be of 4 types. One-to-one, one-to-many, write it like this. One-to-one or one-to-one, one-to-many, M or N, whatever, one. Many-to-many, sorry, many-to-one, and then many-to-N. These are the various kinds of cardinalities, or you even say mapping constraints, which can happen in a binary relationship. Now let's see, what do you mean by each, and then how you can represent them. Now let's see. We are going to talk about 2 entities called A and B. Now, if each entity in A is mapped exactly to one entity in B, and even vice versa. every entity in B is mapped exactly to one entity in A, you say it is 1 to 1. You read from left, it is 1, and even when you read vice versa, it is 1. You say it is a 1 to 1 entity, a 1 to 1 relationship. Okay, A1 to B1, B1 is not mapped to anybody else other than A1. You say it is a 1 to 1 relationship. Look into the next diagram called B. We have two entity sets A and B. Look here. A1 is mapped to more than 1. A1 is mapped to more than 1. A2 is also mapped to more than 1. A3 is mapped only. I can say this is a 1 to many. This is a 1 to many. 1 is mapped to more than 1 entity. You say it is a 1 to many relationship. Now, many to 1. Many in A are mapped to a single entity in B. I say it is a many to 1. Okay, many to many means look here. Many, 1 over here is mapped to many. And then if you look at the reverse, many, look here. Many is mapped to N. So, you know, a combination of these, you can say it is an M to N relationship. Okay. You have a 1 is to M over here. You even have a M is to 1 over here. M is to 1 over here. You combine both, you do have a many to many relationship. These are basics which you have in mathematics. Now let's see how you denote it in your ER diagram. Now look, just have in mind this much. Wherever you have 1, you will be representing it with this arrows cap. You will have a cap. Okay. Whenever it is an M or an N, it's a simple line. It's a simple line. So whenever you have an 1, have in mind, you will have this arrow thing. Okay. Now look, instructor and student. If it is a 1:1 relationship, I will be having arrows both, which means an instructor can teach only one student. And that one student can be taught only by that teacher. Okay, let's say I do have a teacher called Anne. Okay, and I am teaching a student called Alfie. If it is a 1-to-1 relationship, I can teach only Alfie. And Alfie, she can be taught by no other teacher except Anne. You can think of homeschooling. Homeschooling where the parent itself teaches the student. Imagine you have a homeschooling where there is only one kid in the family. That parent teaches only that one kid. And that one kid is taught only by that parent. A 1:1 relationship. Okay. Now, let's see how to denote a 1-to-many. 1-to-many, as I told you earlier. 1, you will have that arrow mark. And you know that many part, you will have that simple line. Okay. So 1-to-many. Okay. That one portion, you will have the arrow mark, and the many portion, it will be a simple line. So here it means instructor can teach many students. I am an instructor. I teach all 60 of you. Okay. I am teaching all 60 of you. You call it a 1:many relationship. At the instance, if you think of it like this, the 60 of you can be taught only by me, no other teacher. You talk the reverse. Okay. many students can be taught by one teacher, which means, many of you, 60 of you, you can be taught by only me. That is what you mean by a 1:many relationship. The next, many to one. If you think about the notation, as I told you earlier, many to one, many you'll have a single line, one portion you will have that arrow. Okay, so many instructors teach one student. Okay, so if you think about the student called Atira is taught by many of us. Okay, Anne teaches Atira, Sue teaches Atira, Shiju teaches Atira, Father Angelo teaches Atira. Okay, and Atira is taught by all of these people. Okay? Many to one. Many instructors teach one student. You think there was one student is being advised by many instructors. One student advised by many instructors. This is how you denote a many to one relationship. Now, many to many, as the notation goes, many, many. No arrows anywhere. Many to many, which means M to N. Many instructors advise many students. This is actually the scenario which happens now. Okay, you 60 are there. You 60 of you are being taught by many of us. Anne teaches you, Shiju teaches you, Father Angelo teaches you, Kirti ma'am teaches you. Okay, many students are being associated with many instructors and even the reverse. Many instructors, they are being taught, they are being dealing with many students. M is to N. You don't have arrows anywhere. Okay, so this is how you represent a many to many. So always keep in mind, whenever you draw an ER diagram, you should be denoting the cardinalities. Okay, you should be denoting the cardinalities. Okay, now there is something called total participation and partial participation. Total participation, you usually denote it with a double line. It means each entity in the entity set participates in at least one relationship. Okay, I'll show you with the help of. Let's see. You do have an A and you do have a B. And let's say I have A1, A2, A3, and A4. B1, B2, B3, and B4. Okay, I have an entity set called A, where I do have 4 entities, and I even have B, which has 4 entities. Now look here. If you look into the entity set called B, all the entities, B1, B2, B3, B4, they all participate in a relationship. Okay, so I say this is total participation. If you look into all the, you just have 4 entities, and look here, all the 4 entities, they are participating. B1, it is related to something, B2 is related, B3 is related, B4 is related. So I say this is a total participation. Total participation of the class in an event, which means every student in the class joins for some program or total participation. Okay, so if it is a total participation, I denote it with double lines. Okay, now look here. A1 participates, A2 participates, A3 participates, but that entity called A4, he is a lazy guy, he did not participate. Okay, he did not participate. I do not say this is a total participation. I say this is a partial participation. Okay, partial participation, single line sentence. Total participation, you denote it with double lines. One more thing we need to learn in cardinalities: minimum and maximum. Minimum cardinality and maximum cardinality. Okay. Now look here. Sometimes you might not be able to exactly tell whether it is a one-to-one or a one-to-many or a many-to-one or a many-to-many. Many means actually it is any number. Many means it is any number which is greater than 0 or 1. Okay. It can even be, it can take any number. It can take any number. Okay. Now let's say, imagine you have a scenario like this. Instructor and student, okay, teachers. Now, let's imagine your class has a strength of only 60. Okay, nothing more than 60 can happen. Anything less than 60 is fine. Anything less than 60 is fine. But your class cannot have a strength more than 60, which means that I will not be able to teach more than 60 students in a class. So I can write over here, let's say 1 to 60. A minimum of 1, even though there is only 1 student in the class, I will teach him. Okay, up to a maximum of 60. 61? No, impossible. Okay, so this is called minimum cardinality and this is called maximum cardinality. Okay, sometimes let's say teaching 1 student is really bored, isn't it? I can instead say 5 to 60. Starting from 5, fine for me. Okay, so this is minimum cardinality and this is my maximum cardinality. So always it need not be 1:1, 1:m, m:1 or m:2. You can set cardinalities. The user can set cardinality. What is the minimum cardinality and what is the maximum cardinality? So the same way, even the other side, you can be setting cardinalities. So that is what you mean by minimum and maximum cardinalities. Okay, do you want a break?